Okay, my secondary math 1 class. We are going to be practicing simplifying radicals some more today, but we're also going to be learning how to add and subtract those radicals. Okay, that's going to be at the very end of this video. So first, we are going to do what we've been doing for the last couple times. Okay, so for number 1, we are going to list, just like we've done, like this will be the 3rd time, but it helps. Okay, we're gonna list the first 11 perfect squares. Okay, so on your paper, let's make a list from 0, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so let's make a list from 0 to 10, just like we've been doing. Okay, next step, I want you to multiply these numbers by themselves. Okay, so now all your numbers are multiplied by themselves. Okay, well now let's figure out a way to rewrite all of these guys. Okay, so 0 times 0, we can also rewrite as 0 squared. Okay, so let's do the same thing for all of our numbers. 1 squared. Okay, so now we've just rewritten all of them, okay? So it's the same thing, okay? We just are rewriting. 0 times 0, we can also rewrite as 0 squared. Okay, well now let's go ahead and figure out what are these numbers. Okay, well 0 squared, or 0 times 0, really equals 0. Okay, what is 1 times 1, or 1 squared? It's going to give me 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6 is 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. And 10 times 10 is 100. Okay, so we've made our list of the first 11 perfect squares. 11 because if we go from 0 to 10, we get 11. Okay, so now what I want you guys to do is just looking at 2 through 5. Okay, so let's just look at 2 through 5. See if any of these numbers inside your radicals are also on your list, okay? So take a second, look at 2 through 5. See if any of those numbers are on that list. If they are, I want you to put a star by them. Okay, so it looks like the only one that would be on that list is number 2, because 16 is on our list. Okay, awesome. So that's gonna help us. So let's zoom in to number 2. Okay, well we put a star by 16 because it's also on our list. Meaning, what number multiplies by itself to give me 16? This is going to be easy peasy. We know that 4 times 4 gives me 16, and the whole point of simplifying radicals is to try and find that pair, that couple that gets to leave the radical and go on a date. Okay, so these 4 created one couple that got to leave, and no one had to stay inside. So we know that the square root of 16 is 4. Okay, I'm going to zoom out just a little bit. It's a little close. Okay, so let's look at number 3. We have the square root of 12. 12 is not a perfect square. So we are going to have to start dividing this down, breaking it down. Okay, so how do we want to divide 12? Okay, and it doesn't matter how you divide it, we're still going to get the same pairs that get to come out. Okay, so I can see that 12 is an even number, so I'm just going to go ahead and divide it by 2. Okay, so I know that 12 divided by 2 is going to give me 6 on that side. Okay, 2 is as broken down as it'll go, but I can still divide 6. So how am I going to divide 6? Well, it's an even again, so I can divide it by 2, and that's going to give me 3. Okay, so all of these numbers are as broken down or divided as they can be. So what is my number that can pair up and go on a date? Okay, I see that I have a pair of 2s. Okay, don't look at 12 and 6. We broke those down. They're not there anymore. Okay, so these 2s created one couple that could leave my radical and go on a date. But what is the sad third wheel number that has to stay in? It's going to be that 3. Okay, so our final answer is 2 root 3. Okay, let's look at number 4. So we have the square root of 50. So 50 was not a perfect square number. We got close, we got to 49, but there's no 50 on this list. Okay, so we need to divide it down. Okay, so how can we divide 50 down? Again, it's an even number, it ends with a 0, 2, 4, 6, or 8. So I can divide it by 2. Okay, what is 50 divided by 2 going to give me? 25. Okay, so I have 50, well, I broke 50 down to give me 2 and 25. I can't break 2 down anymore, but how can I break down 25? It's not an even number, but what special number is it? Ooh, nice. I like 25, okay? This automatically gives us a pair of numbers. So I can divide 25 by 5 and 5. Okay, and that's an awesome number because, like I said, it automatically gives us that pair. So these 5s can couple up. They make one couple, so only one 5 leaves. They turned into one couple that can go on a date. And then there's one sad 2 that had to stay inside. So our final answer is 5 root 2. Alrighty, let's look at number 5. Okay, so for number 5, we need to break down 18 because we know it's not a perfect square. So let's go ahead and divide 18. How do you guys want to divide 18, or how are you going to? Okay, I see that it's even again, so I can go ahead and divide it by 2. Okay, well, what is 18 divided by 2? It's going to give me 9. Okay, I can't break 2 down anymore, but again, 9 is on this list. Ooh, yay. So that means I automatically can get a pair out of 9. 3 and 3. Okay, so here's my pair. They create one couple, so 1, 3 got to leave the radical, and then 1, 2 had to stay inside. So our final answer is 3 root 2. All right. Okay, 6 through 11. These guys are a little bit different, okay? And I definitely don't want you looking at 10 or 11 yet. Let's just look at 6 through 9. Okay, so 6 through 9 on your paper, we see that there are actually numbers in front of our radical. We didn't have that before. Okay, now we have numbers in front of our radical. Okay, but that's okay. We are going to ignore them for the first little minute. Okay, so just think of this like if we're trying to get pairs to go on a date, think of this as a couple that's already waiting outside, see if anybody can go on a group date, okay? So we're gonna ignore them for a second, and we're just gonna break down these numbers. Okay, 400 is a big number, and off the top of my head, I don't know if it's a perfect square. Okay, so I'm just gonna start breaking it down anyway. Okay, so 400, how do we wanna break 400 down? So there are a couple ways here. So I see that it ends in a 0. So if you ever see that, we know we can actually divide it by 10 if it ends in a 0. Okay, so what is 400 divided by 10? It's going to give me 40. Okay. Whoops, sorry. Just bumped my table. Okay, how can I divide 10? Because we're trying to see how many pairs we can get out of this. So let's divide 10. Okay, I'm going to divide 10, because it's even, by 2 and 5. 2 times 5 gives me 10. Okay, but how then can I divide 40. Okay, again, it's even, or it ends in a 10 again. Okay, so we can, or it ends in a 0, so we can divide it by 10 again if we wanted to. So 10 times what gives me 40? 10 times 4. Okay, careful not to look at that 10 before. We broke it down. So our only numbers we are dealing with are 2, 5, 10, and 4. Okay, we don't have any pairs out of these yet, but let's keep breaking it down. So 10, we know we can break down. We already broke it down once. Okay, so let's break that down to a 2 and a 5. Nice. Okay, and 4 we can break down to a 2 and a 2. Okay, a lot of numbers here. So don't look at the numbers that we've broken down. Only look at the numbers, sorry, this is kind of hard. Only look at the numbers that are on the ends of your factor trees. Okay, what pairs do we see? So let's see, I see one pair of 2s right here. I see a pair of 5s right here. And I also see a pair of 2s right there. Ooh, nice. Okay, so let's count how many couples we had. We had one couple of 2, one couple of 5, and another couple of 2. Okay, is there anything else that had to stay inside my radical? No, all of these guys got to come out. So guess what? 400 actually is a perfect square. That's awesome. Okay, so what are we doing with these numbers when they get to leave my radical? What's happening with them? Well, if we're dividing right here, we know once they come out, we are multiplying them. Okay, but we're not quite done yet because remember, there was a couple that was already out there. Okay, it also needs to be multiplied. Okay, so in your calculator, we can put -8 times 2 times 5 times 2. Okay, if you want to do this in your head, you're more than welcome to as well. Okay, but in my calculator, I'm going to do -8 times 2 times 5 times 2. And that's going to give me -160. So my final answer for number 6, -160. Okay, that was kind of a long problem, but it's okay. We solved it the exact same way. The only extra step we had to add in was that multiplication of the number that was already out front, right? Awesome. Okay, so let's do it again on number 7. So again, we're going to ignore the couple that's already out in front, so we're just going to worry about this 210. Okay, so let's divide 210. Well, look at its last digit. What does it end with? Ends with a 0, so that means I know I can divide it by 10. Okay, what is 21 divided by 10? That's going to give me, or excuse me, I just said it. 210 divided by 10 is 21. Okay, awesome. So I don't have a pair of numbers yet, but we can keep breaking it down. Let's break 10 down, divide it by 2 and 5. Okay, so now I have a 2, a 5, and a 21. So I still don't have a pair. Okay, I cannot divide 21 by 2. It is not an even number. Okay, but I can divide it by 3. Okay, 3 times what gives me 21? 3 times 7 gives me 21. Okay, so let's see. All of these numbers are as broken down as they can be. Okay, so do I have any pairs that can leave my radical? 2, a 5, a 3, and a 7? No. Okay, oh my goodness. This turned out that nobody could leave my radical. So they all had to stay in, which means they all multiply back together, which means, oh my gosh, this was pretty much a trick question. No, not really. It's good to know. Nothing can come out of this radical. So this 8 stays out there. The 210 stays inside. Nobody could leave. Sad. Alrighty. Let's do it again on number 8. Okay, so I have 392 that we're worrying about right now. We're going to ignore the -3 for now. Okay, 392. Okay, Okay, well, this is an even number, so let's go ahead and divide it by 2. Okay, so if I do, oops, let me zoom in just a little bit more. Okay, 392 divided by 2 in my calculator. 392 divided by 2, that's going to give me 196. So 2 and 196. Okay, so now let's divide 196. 196 is also even, so we can just take that and divide it by 2, and we're going to get 98. Okay, we might run out of room here. That's okay. 98 is also even. Okay, so let's divide it by 2 again. Divide by 2. 49. Ooh, I love 49. Okay, once we get to 49, we know, woohoo, it's on my list. It'll give me an automatic pair that can come out of there. Okay, so 49 turns into a 7 and a 7. Okay, well, you might have thought that you're wanting to stop right as you get to your first pair, but don't do that, right? We have other pairs that can go on the date. So how many couples can actually go on a date? I see one couple of 2, and again, it doesn't matter which 2s you grab. Okay, so one couple of 2 got to leave. Okay, but then a couple of 7 got to leave. Okay, who had to stay inside? Okay, look at the end of your factor trees. Who had to stay inside? That 2 right there. Okay, we know once they leave, they're being multiplied, but we're not done yet because we had a couple that was already out there, so waiting to be multiplied. Okay, so now we're going to multiply all 3 of these guys together. So what is -3 times 2 times 7? That's going to give me -42 on the outside and that sad little 2 on the inside. And there we go. Okay, we're following the same steps. Okay, so we're going to practice this one more time before we talk about adding and subtracting them. Okay, so let's look at 343. It doesn't end in a 2, so I know I can't divide it by 2, or it's not an even number, excuse me, so I can't divide it by 2. But maybe, let's just see if we can divide it by 3. So 343 divided by 3, what do I get? A decimal. So we know it's not divisible by 2. So let's just keep trying numbers. 343 divided by 6? Nope. 343 divided by 7? Ooh, nice. Okay, so try a number until you get to a whole number, no decimals after. Okay, so we know that 343 can be divided by 7, and that'll give us 49. Okay, sweet. And I love 49 because it automatically gives us a pair. So 49 can then be divided to a 7 and a 7. Okay. So what couple got to leave my radical? One couple of 7 got to leave. What had to stay inside? 1 7. Okay, but we're not done yet because remember there was already a couple that was outside the radical waiting to multiply. Okay, so now we have 6 plus 7, or not plus, excuse me, 6 times 7 we're multiplying. That's going to give me 42 on the outside and root 7 still on the inside. Okay, awesome. Okay, let's look at 10 and 11. Okay, now we see that, oh my gosh, not only do we have 2 radicals, we have to add them. How in the world are we going to do that? Okay, this is actually a lot simpler than you might think. So we're going to treat this like terms. Okay, in fact, I want us to write that on our paper. So treat them like, yes, 2 likes in a row, terms. Okay, we're going to treat it the same way as if we had x plus x, y plus y. Okay, so the first thing we have to do is see if our radicals, the numbers under our radicals, are the same. Okay, so we're going to look. So in my first one I have root 2. my second one, I also have root 2. Okay? Since they are the same, these guys are like terms. They have the same number inside their radical. Okay, so now all we have to do is look at their coefficients. Super simple. Okay, we look at this 4 and we look at the 4. Okay, what is 4 plus 4? Okay, this is like saying I have 4 of something and I'm adding another 4 of something. How many of that something am I going to have? I'm going to have 8. Okay, and what is that something? Well, it's 8 square roots of 2. So our final answer, 8 root 2. And that is it, you guys. That is all we're doing. Okay? All you have to do is make sure that the numbers inside your radicals are the same. Sorry, camera's a little shaky. And then if they are, add or subtract their coefficients. This one was 4 plus 4. 8 root 2. Nice. Okay, let's look at number 11, our last example. Okay, so look at your radical. Look at the numbers inside your radical. I have a root 3 and a root 3. Are these guys like terms? Yes, they are. They both have root 3. Okay, so now all we have to do is look at the coefficients again. So this time I have negative 4 and I'm subtracting 4 more. What is negative 4 minus 4 more? Okay, we're getting more negative here. Negative 4 minus 4. It's going to give me negative 8. Okay, well, excuse me, can't talk. Okay, well, what is those somethings that we're subtracting? It's negative 8 root 3. And that is our answer. Okay, those are your notes for today, you guys. You have an assignment that goes with it. Make sure your notes are filled out. It's going to make it a lot easier if you're working from home, okay?